Hi, this session is about data drift. So, what happens in data drift is, say, suppose a model is trained on attributes 1 to 4 and they have a value range 1, value range 2, value range 3, value range 4, and suddenly the data changes and the range of the data that is there for the attributes changes to different, say 1a, 2a, 3a and 4a. What happens is that you have trained the model on this type of data, and when you predict it on a different set of data which has a completely different range or a completely different set of data, the prediction might not be correct. So that is known as the data drift. So let's jump on and see a much more formal way in Azure Docs. So what is data drift? Data drift is one of the top reasons model accuracy degrades over time. For machine learning models, data drift is a change in model input data that leads to model performance degradation. Monitoring data drift helps to detect these model performance issues. What are the causes of data drift? Upstream process changes, such as a sensor being replaced that changes units of measurement from inches to centimeters, data quality issues, natural drift in the data, change in relation between the features or covariate shift. So let's jump into a notebook and see of how we can monitor data drift. So we have to install this package Azure ML data drift, and then what we do is that we connect to the workspace. So I have already created a workspace here. So the workspace is already here, and what I do is that this is a workspace WSAG, and I have downloaded the config.json file, and this is how I am connecting to the workspace. Then I am creating a baseline data set. What we are doing is that we are uploading two files, diabetes.csv and diabetes2.csv, and then we are registering and making a baseline data set. So if I go down here, if I go to these data sets, this is a baseline data set, and here if I go down here, what is the baseline data set? Let it come up. So these two are the baseline data set. Okay. Now next is we create a target data set. So what is the target data set? We are reading a data file which is diabetes2.csv, and for the past 6 weeks what we are doing is that we are changing the pregnancies data, we are changing the age data, we are changing the BMI data, and then we save the file with another name, and then what we do is that we are uploading the data week by week into our default data store, and also we are registering the data set. So this is the code for it. Note one thing, for each week we are changing the data, and we are changing the data in this manner. We are making the pregnancies data +1, and we are making the age data quite significant, 1 into 1.2, and then the BMI data multiplied by 1.1. So what happens is that if I go back and if I go to the data set, so this is my target data set, and if I go down here, you will see, let it come up. So you will see that there are 1, 2, 3, 4, 5, 6 for 6 weeks. So these are the data sets, and this has got the change data. Now we go back to the program, and then what we have done is that we will now create a data drift monitor. For that we are creating the compute target, which is the cluster. The cluster is already been created here. So if I go into compute, In the compute cluster, the cluster is already created. So it is a standard DS11 V2 machine that has been created. Next, what we do is that we define the data drift detector. So what it does is that you have the workspace, you have the data drift detector name, you have a baseline data set, you have a target data set, you have a compute target, you have the frequency, you have the feature list. So what are we trying to track is these are the features: pregnancies, age, BMI. There is a drift threshold is there, and the latency is 24 hours for the data collection. Then what we do is that we backfill the data drift monitor. Let's go a little bit slow. So we have a baseline data set which we have shown, a target data set that includes a simulated weekly data collection for 6 weeks. We can use this to backfill the monitor so that we can analyze the data drift between the original baseline and the target data. So we do a monitor.backfill, and this is the same, this is a date, a range, and this is the another date range that we are giving. So then we do a backfill, and once we do a backfill and run it, we can analyze that what is the data drift. So it shows that this is a start date and the end date, and the days from start is this, and the drift percentage is given here. So it shows quite a considerable amount of drift, and you see as the weeks go by, there is a major drift from 74% to 99%. We can also see the data drift if I go to data sets, if I go to data set monitors. You see this is the data drift here. Let it come up. So here is a data drift, the 99% is a data drift that is there, and you can see that which feature is contributing to the data drift. The BMI is giving the which one is giving the most? Age is giving the most drift, followed by the BMI and then the pregnancies, which is expected because if you go back and see the code down here, what we have done is that we have multiplied by 1.2 the age, so that defines the most drifting of the data, and the BMI is also the 1.1. So this is what the data drift is. If you just go back and reflect on what we explained here, you see this had a value range, and then another value range was coming because of the new data coming in, and that is why this is the data drift, and this is how we can monitor a data drift. So what happens is that when you detect a data drift, you can spin off another training so that it is trained on the new data. So this completes the session on data drift. Hope you liked it.